Welcome to lesson 10. So today we have a couple things to get through. So we'll try to get through them somewhat quickly in the time that we have. And we're going to start by talking about division by zero. So let's get started with that. And to begin with, we're just going to do a quick review on the idea of inverse. So you recall, we talked about this before, that there are inverse properties or inverse operators here. So if I have 6 plus 2 equals 8, if you recall, we talked about what's the inverse of addition? And the answer is subtraction. So if we start with a 6 and we get to an 8, by addition, we should be able to get back to the 6 by using subtraction. So to do that, we're going to start where we left off with the 8, and we're going to say the 8, and now we're going to use subtraction, minus the 2 equals the 6. So we got right back to where we started. We started with a 6, and now by using our inverse operator here for addition, which is subtraction, we end up getting back to our 6. Right? Started with 6, ended with 8, but then we started with 8 and got back to our 6. All right? All because we were able to use our opposite operation. So you have the plus, and the opposite of that is minus. Okay? Now recall that also works for multiplication. So just real quickly here, let's just take a multiplication problem. If I have 3 times 4 equals 12, now I started with a 3 and I got to a 12 by using multiplication. If I want to get back to the 3, I use the inverse operation, which is what? What's the inverse of multiplication? Division. So we're going to divide, and we're going to start with our 12, and we're going to say 12 divided by the 4, and that'll give us 3. So once again, we started on a certain number, and by using multiplication we got to the 12, and then using that answer, the 12, we used the inverse operation, which was division, to get back to our 3. So we started with the 3, got to the 12, started with the 12, and then ended up with the 3, right back to where we started. So keep in mind, this is just a review, but the subtraction is the opposite of addition, or the inverse of addition. Multiplication is the inverse of division. All right. So keeping that in mind, let's take a problem. Let's say we've got, I'm going to change back to my black here. Let's say we've got 6 over 2. Now, recall that 6 over 2, that's just another way of writing 6 divided by 2. Okay? So we could also write that as 6 divided by 2, which is equal to 3. All right? And again, if I asked you to use the inverse operation, what would I do here to get back to the 6? Well, the answer is to take our 3 and now use the inverse operation, which is multiplication, times our 2, which then gives us back to the 6. All right? So now let's try something different. What if I give you another problem that looks like this? Let's go with a 3 over 0. Make it a little interesting here. So what happens here? Well, if we kind of follow the same thought process that we used over here, we would say, okay, another way to write that, just maybe so it makes it a little bit clearer, would be 3 divided by 0, which is what? That is the question. What is 3 divided by 0? Let you think about that. 3 divided by 0. What would the answer be? Well, you might have thought, okay, 3 divided by 0, I think that's probably 0. Let's try that. Okay? Now, if that's true, and if it's true that multiplication is the inverse of division, then I should be able to use this 0 to get back to the 3 by means of multiplication. So just like we did in these other problems, I can take this 0, and now I multiply it by this 0, and that should give me 3, but it doesn't. Now, we were trying to get the 3 here so that we would get back to where we started, but 0 times 0 is not 3. So that does not work. 0 times 0 is, in fact, 0. So we have a problem here. We did the same thought process, the same steps as over here, but the problem is it didn't work out in this case. So what went wrong was our answer here. What is 3 divided by 0? Well, it can't be 0. It can't be, because that doesn't work when we use the multiplicative inverse property when we go through this. So if the answer is not 0, what is it? And I'll let you think about that for a second. If it's not 0, what would it be? 3 divided by 0 is what? Well, the answer is, you ready? I don't know. I don't know what the answer is to 3 divided by 0. As a matter of fact, no mathematician does. 3 divided by 0 is undefined. And that's the way we answer that question. We say, we don't know. It's undefined. Okay? Which basically means we don't know the answer to it. So if you ever see a problem that has division by 0, so it might look like this, 6 divided by 0. The answer is undefined. I don't know. Just undefined. We don't know what the answer is to that. And this could be any number on top, or we could write it the other way. We could say, what's 13 divided by 0? The answer, undefined. Okay, so keep that in mind. It's very, very important. Anything divided by 0 is undefined. We simply don't know the answer to it. All right, now, just so that you don't make this mistake, what if I were to say, 0 divided by 6? Now here I have the 0 in the numerator, not in the denominator. Is this possible? Can we do something with this? Well, 0 divided by 6, if we write it this way, let's say, I'm going to say the answer is 0 for this. Okay, now if we picture it that way, and again we use our multiplicative inverse here property, since we're using division, we should be able to get back to this original 0. So we take the answer 0 and we multiply it by our 6, and what does that give us? 0. Excellent. So these two match. We got to where we started. We undid or reversed the operation and got back to where we began. So in this case, yes, this does make sense. 0 divided by 6 is in fact equal to 0. Okay, that makes sense. So if the 0 is in the numerator, it's fine. The answer is 0. If the 0 is in the denominator, the answer is undefined. We do not know. Okay? One more. Let's take this one now. What if we have a problem where we have, well, let's see here. Let's go with, actually, let's do this one. 5 times 0 equals 0. And now let's use our reverse operation, our division, to get back to where we started. So if we take our answer, which is 0, and we divide that by this number, which is also a 0, what do we get? 0 divided by 0 is, we don't know, because we have 0 in the denominator, right? So that is undefined. We don't know what this problem is here. So if we don't know what that is, oops, help if I could spell here. Okay, so that is undefined. So when we take a number, or if we take 0 divided by 0, I should say, that answer, you might say it's undefined, but we actually have a different wording for that. Because it's 0 over 0, we actually are going to call that indeterminate. Okay? All right, so there's a little bit of a difference here. It's not really undefined. I'm going to cross that out. Okay, if 0 is in the denominator, we call it undefined. If it's in the numerator as well as the denominator, such as this, then we call it indeterminate. Okay, now that might not make a whole lot of sense to you right now, but much later in your algebra studies, that will make more sense, and we'll be able to do certain things with 0 divided by 0 that we weren't able to do with, say, something like 6 divided by 0. So for right now, you need to keep in mind the difference. If it's 0 in the numerator and the denominator, it's indeterminate. If it's 0 in the denominator only, then it's undefined. All right? So pretty straightforward. But bear that in mind. All right, so before we go on any further, let's just try a couple of practice problems here. If I have something that looks like this, 6 plus 3 minus 2 minus 1 all over, I don't know, let's say 12. All right, how would we go about doing this? Just to make sure you understand this process. This is pretty straightforward. All we do is simplify the numerator. 6 plus 3 is 9. 9 minus 2 is 7. 7 minus 1 is 6. And our denominator is just a 12. We can reduce this to get to the 1/2, right? So when we have fractions that have expressions in the numerator that can be simplified, like everything we see up here, we always simplify those out before we divide them by 12. Makes it easy. All right. So if we have something that looks like, I don't know, let's say 5 minus 3 plus 6 minus 4 minus 2 all over a 12 minus a 10 plus 3 minus 5. All right, let's do that one. So we're going to have 5 minus 3 is 2. 2 plus 6 is 8. 8 plus a negative 4 is a 4. And then 4 plus a negative 2 is a 2. Right? Down here we have a 12 plus a negative 10, which is going to be a 2. A 2 plus a 3 is going to be a 5, and then a 5 minus a 5 is going to be a 0. Now, notice what happened. We ended up with 0 in the denominator. So right away, we can end our problem by saying undefined. And that's our answer. Undefined. All right. Let's try one more. What if we have something like this? All right, so we have 6 plus 7 is 13. 13 minus 5 is going to be 8, and then 8 minus 8, well, that's going to give me a 0. And then on the bottom, you know what? I might not even worry about the bottom, although, well, I should still do it because this might still be 0. 3 plus 2 is 5. 5 minus 4 is 1. 1 plus 3 is 4. So we have 0/4, which is going to equal what? 0. Because here, the 0 is in the numerator. So that is our answer. All right. And of course, we could do one more. All right. So we have 3 minus 5 is a negative 2. Negative 2 plus 6 is a 4. And then a 4 minus 4, that's going to be a 0. And then in the denominator, we have 3 minus 3, which is also 0. So what's our answer? Well, this one is indeterminate. Which is kind of another way of saying we don't know what the answer is, but we're making a little bit of a, stipulation here. It's not the same as undefined. So they kind of look the same. They're both something we don't understand right now. But again, indeterminate, we'll be able to work with that a little bit in the future, but we never really are able to work with undefined. So that's why we define them as such. All right. Now, next, we're going to talk about, if I clear the page here, we're going to talk about the commutative property of multiplication. So this one's pretty straightforward too. So we already talked about addition and subtraction. If I have, 2 plus 4 minus 2, plus 1, right? If I have something like this, because addition is commutative, which means that we can add this in any order we please and still get the same answer. So I might say, okay, well, let's take, and maybe we'll go a different color here. Let's take, you know, the two. Oh, where's my other color? We'll take the 2 and the 4, and we'll combine those two first, and that'll give us a 6, right? And now we could have, you know, our 6 minus 2 plus 1, and then maybe we take, okay, well, let's go from there to the 6 minus 2 here, just kind of working our way down the line. 6 minus 2 is 4, and then of course we still have our plus 1 on the end, and we'll say, okay, that's 5, right? Now, we could also do this in a different way. We could reorganize it. We might start with the problem again, 2 plus 4 minus 2 plus 1. And maybe here, we'll do it a little differently. Maybe here we'll say, you know what, let's start with this 4, this positive 4, and this negative 2. Let's add those two together first. And if we add a positive 4 and a negative 2, we end up with a 2, a positive 2, right? Okay, now we still have left over from the rest of the problem this positive 2 over here and this positive 1 over here, right? Now we can add those together. And we have 2 plus 2 is 4 plus 1 is 5. All right, so we still got the same answer. 5 here, 5 here. We just approached it differently. Here we kind of worked our way down the line. Here we kind of started in the middle and then added the rest to it. Still get the answer of 5. In addition and subtraction, it doesn't matter which one you do first. You can pick and choose the order. All right. Now, when we're dealing with multiplication, the same thing applies. So if I have 3, and I'm going to say times a 4, and then maybe, you know, times a 2 times we'll go another 2. All right. So if I have something like this, 3 times 4 times 2 times 2. Remember, when we have something in parentheses right next to each other without any positive or negative sign, that indicates an invisible operation, the multiplication. If you wanted to, you could put little dots in between here, if that helps you to remember that. But there's invisible multiplication going on between these parentheses because there are no addition or subtraction signs. All right. So once again, I might start with, you know, just kind of going down the line again. If I start with the 3 times 4, that would give me a 12. And then I have, you know, what's left over here. I have my times 2 and times my other 2. And maybe here I'll even take, you know, these two here and combine those. 2 times 2. Well, that's 4. And then of course we have the 12 still. So we have 12 times 4, and that'll give us a grand total of 48, right? Now let's do the same thing, but we'll do it in a different order. So we have 3 times 4 times 2 times 2, and now we will start with, let's see, we started with the 3 and 4 last time. Let's just start with the middle again. We'll do the 4 and 2 this time. So if we multiply 4 times 2, we have an 8, right? And then we have left, I should probably do this the same way I've been doing it before. We'll go back to a black color here. We have left over the 2 on the end, and we have the 3 in the beginning, right? And now I could say, okay, well, what next should I multiply together here? Again, I can pick and choose. I could do the 3 times 8, or I could do the 2 times 6, or 2 times 8, or the 2 times 3. Let's actually really go wild here. Let's take this 2 and multiply it by this 3. Since they're all being multiplied together, we can rearrange them completely. If we take those 2, multiply them, we get a 6. And then if we take that 6 times what's left over, which is the 8, what do we get? We get the 48 again. So answers are the same. So again, in multiplication, it doesn't matter which order you do things in. You'll always end up with the same answer. All right, let's try another one here, but we're going to throw in a couple of signs just to make it a little bit more challenging maybe. So if we have a negative 2 times a 3 times a negative 4 times a negative 2, right? Maybe I'll give you a few seconds here and on some scratch paper, just kind of work that. See what you get. or if you want to pause the video, that might be a better way to do it. Let's do that. Why don't you pause the video, take a piece of scratch paper, and just try to solve that. And when you're done, hit play, and we'll go over it together. All right, so hopefully you solved this on your paper at this point. We're going to go through it, and I think I'm just going to approach it from left to right. That seems to me to be usually the easiest approach. So if I take the -2 times the 3, remember a negative times a positive is going to be a negative, so we're going to have a -6, right? And then we have what's left over, the -4 times the -2. All right, now we'll take it one step further. What's the -6 times the -4? Well, now we have a negative times a negative, so that's going to be a positive. 6 times 4 is 24, so we have a 24 times our -2, which is left over. And now we have a positive times a negative, so our answer is going to be in the negative. Negative 24, or excuse me, 24 times 2 is what? Is -48. So we get an answer of -48. All right. And then I think we're going to try just one more here. I'm trying to kind of give you a bunch of them here so you can see them in different ways. Oh, let's see here. Let me pull out a good one. Well, you know what? I think that might be good. We'll stop that. So let's move on. Let's go on to something that's called unit multipliers. Now, you've been doing some work with this already, but I do want to go over it with you. We didn't get a chance to go over it in a video, and that has to do with unit multipliers. Okay. And its problems, they might give you something like, let's see here. If I have 48, inches, and I might say use unit multipliers to convert 48 inches into feet, let's say. All right, this is what you've been doing before. This is all review. And you've been using unit multipliers to do that. Now, I might just take a minute here and talk about unit multipliers just to make sure that you've got this clear. So if we have a unit, pick your favorite unit. Let's pick inches. Maybe that's your favorite unit. All right, so we're going to talk about inches for a second. There are unit multipliers that involve inches. And a unit multiplier, the key to a unit multiplier is remembering that it needs to be equivalent to 1. I'll say that again. It needs to be equivalent to 1. All right. So if we think about inches, what do we know about inches? Well, we know that there are, 12 inches in a foot, right? Okay, so one unit multiplier for, our inch unit here would be 12 inches over 1 foot. All right, now you might say, how in the world does that equal 1? Well, let's think about this for a second. What happens if I have a fraction where the numerator and the denominator are the same number? So if I have something like 3 over 3, what does that equal? Well, that equals 1. Okay, well, what happens if I have something like 2 plus 1 over 3? Doesn't look like they're the same in the numerator and the denominator until you add them up. Well, 2 plus 1, that's a 3 over a 3, which is a 3 over 3, which is a 1, right? So this is, in fact, equal to 1, right? And you could get, more complicated. You might have, 4 times 2 times 3, for example, over, let's go 24, right? And you might say, is that equivalent to 1? Well, let's find out. What's 4 times 2? 4 times 2 is 8. 8 times 3 is 24. So we have 24 over 24, which is equivalent to 1. All right? So whenever you have a number that is equal in the numerator as it is in the denominator, then it's always going to be equal to 1. All right. So looking at this, what do we have here? We have 12 inches over 1 foot. Well, isn't 12 inches exactly the same thing as 1 foot? They're equal. It's the same thing, just written differently. So we have, 12 inches in the top, 1 foot in the bottom. This is equal to 1. Okay? Every unit multiplier has to be equal to 1. This is our unit multiplier, and it's equal to 1 in this case. Okay? So that's perfect. Now, I might also write a unit multiplier like this, 1 foot over 12 inches. That's also a unit multiplier, and it's a unit multiplier for inches. It has an inch in it, and that's all we need. You just need to have an inch in there for it to be a unit multiplier for inches. And if we look at it, 1 foot is exactly the same thing as 12 inches, so yeah, that equals 1. So that's also a unit multiplier. All right? Now, the next thing to remember, and this is easy, but remember anything multiplied by 1 doesn't change in value. So if I have a 8 and I multiply it by a 1, the answer is an 8. The 8 does not change. It stays the same. If I have, a smiley face and I multiply him by 1, he's a smiley face. Nothing changes. All right? That's the way multiplication works. All right. So getting back to the problem over here, if we're trying to convert 48 inches into feet, let's think about what we're trying to do. We're trying to take something that's from inches and we're going to feet. Okay. So how do we get there? Well, we're going to think about our unit multipliers for inches. And the two that will probably come to your mind first are the two that we already described over here. You've got the 12 inches in 1 foot and the 12 inches over 1 foot, or the 1 foot over 12 inches. So think of those unit multipliers when we're trying to go from inches to feet. Okay, so we have 48 inches. Another way to write 48 inches as a fraction would be 48 inches over 1. Remember, a fraction is the same thing as division. 48 inches divided by 1 is 48 inches. So I can write 48 inches as 48 inches over 1. All right. So I'm going to multiply this by a unit multiplier. And remember, our goal is to get something in feet. Okay. So if our goal is to get something in feet and we have inches in our numerator, let's look for a unit multiplier with inches not in the numerator but in the denominator, on the other side of the fraction. So we're going to use this one, the second one here. Okay, so if we multiply this by 1 foot over 12 inches. Okay, now let's stop for a second and just verify, can I do this? Am I changing the value of this 48 inches that I started with? Well, no, I'm not, because 1 foot over 12 inches is equal to a 1. So if I multiply this 48 inches by a 1, I'm still going to get 48 inches. I'm not changing the value of this number. Okay, so we're not changing the values here. We're just multiplying this by a very odd looking 1. Okay, now we remember that in multiplication we can cross cancel. You learned that a long time ago. So we can say, oh, well, let's see, 12 can go into itself once and 12 can go into 48 4 times. Okay, so that simplifies things a bit. But not only can we cross cancel numbers, we can also cross cancel units. That's a beautiful thing. So if we if we notice that they both have inches, we could cross cancel out. How many inches here? We've got 1 inch, so that can go into itself once. It can go into itself once over here. So we just eliminate them. The inches, they eliminate each other. They cross each other out. Okay. Now, the beauty on that is we're left with no other units in this whole problem except for feet. That's all that's left. And that is what we're trying to get to, is feet. So do you see now why I chose the second one? Because it would cross the inches out. The 48 inches would get crossed out by this 12 inches over here. If I had chose the first one, well, I wouldn't have been able to cross out because I would have had inches in the numerator over here. In the denominator, this would have been feet over here. In inches, I can't cross cancel feet and inches, so that would have been a mess. But because I chose this unit multiplier, I was able to cross those inches out. Now I can continue multiplying and go, well, I'm left with only a 4 times a 1 foot in the numerator, which is going to give me that 4 feet. All right, I'm just kind of moving that foot variable down next to it here. And then on the bottom, well, I've got, well, 1 times 1, which is 1. So I have 4 1 foot, which is the equivalent of 4 feet. All right. So now I've just converted, I started with 48 inches. I've converted that into feet, 4 feet, in fact, by using unit multipliers. So hopefully that makes sense. And that's, again, this is a review from what we've done before. But I'm going to use that because today we're going to make this just a shade more complicated. So what happens if, let me pull up a problem here that'll illustrate what I want to do. All right, so let's just say we've got, we'll start with an easy one. So let's say we've got 36 inches squared, and I want you to convert 36 inches squared to feet squared, or square feet, using unit multipliers. Okay. So really the only difference here compared to the problems we've done before is now we're using squared units. All right. So think area. That's really what we're using here. Area. If I have, a room, or this is, I guess, a little bit small for a room, but if you have a space that measures 36 inches squared and you want to convert that to feet squared, we have to figure out a way to do that. All right, so here we have inches. Let's just think about this for a second. We're trying to take inches squared and we're going to feet squared. Okay, so we want to think unit multipliers that involve inches. Well, again, that's these two over here. Those are the most common two you're going to think of. So here, though, the difference is we've got 36 inches squared. And I'm just going to put that over 1 as a fraction. And we're going to say, what unit multiplier should I use? And I'm trying to get this, eventually to equal something, feet squared. Okay. So 36 inches squared, what unit multiplier can I use for inches? Now remember, the goal is to cross these inches out. So we need something in the denominator that has an inch, right? And if we look over here, we go, okay, which one is the one with the inch in the denominator? It's the second one again. So we have the 1 foot over the 12 inches, right? Now, this looks great, but the problem is, think about what inch squared means, okay? Inch squared, I'm going to maybe put this over on the side here, and I'll do it in a different color so it stands out. But inch squared, that is equivalent to inch times inch. All right? Whenever you see something squared, that's what it means. If it's a 3 squared, that's equivalent to 3 times 3. Later you'll see things like x squared. That's equivalent to x times x. Okay? So again, inch squared is equivalent to inch times inch. All right? So maybe what I'll do over here is we'll just rewrite this now, maybe in a different color. 36 inches times inches over 1 times 1 foot over 12 inches. Now when we rewrite that inch squared, we have the 2 inches here, and we recognize that, okay, if I cross cancel here, this inch will cross out one of these inches, but I still have an inch left over. I'm not done yet. I still have an inch, and the goal is to get rid of those inches. We don't want inches, we want feet. So what do I have to do? I have to multiply it by another unit multiplier, the same one, to get rid of the other inch. All right, so again, this inch will cross out this inch. Now I've gotten rid of all my inches. And bear in mind that this guy right here, that's just a 1. And this guy right here, it's just a 1. Okay, so by taking this value and multiplying it twice by that unit multiplier, I'm not changing the value. I'm just multiplying it by 1 twice. All right, so our value doesn't change here. We're just using that to eliminate these inches. Okay, so now what are we left over? We got all of our inches gone. In the numerator, we've got 36 times 1 times 1, which is 36. And then we have our units. Nothing over here, but then we have a foot times a foot. Well, that's feet squared, which is what we're trying to get to, right? So we have 36 feet squared. In the denominator, we have this 1 times a 12 times a 12. So 1 times 12 times 12, which would be 144. Now we could reduce this 36 144ths feet squared, but we're just going to leave it like this for right now. That is our answer. As a matter of fact, in your book or even for your homework, if you want to leave the answer as, the 36, and actually I should have pointed out, I guess, we could have cross-canceled this a little bit better. We could have crossed this out and said 12 can go into itself once, 12 can go into 36 3 times. That would have made our answer a little bit nicer. So maybe let's erase that here real quick here. Get rid of this, and we'll just go back to it here. So if we've got the 3 on 3 times 1 times 1, we end up with the 3. There we go. The 3 feet squared over, and then on the bottom now we've got 1 times 1 times 12, which in this case is 12, which actually can be then reduced to 1/4 feet squared. So that's actually our answer. In the book, and actually for homework, if you want to run this all the way down, that's fine. We're going to be dealing with some pretty big numbers though, and the point is just to make sure that you can use these unit multipliers. So if you want to leave your answer as the 36 over, and then on the bottom, you can even go, 12 times 12, and then put your feet squared. That's an acceptable answer as well. It's just not simplified and reduced, but it's still showing that you did all this work correctly. So that's fine. In your book. That way you're not using big numbers and trying to multiply all these big numbers out. You can just keep them as factors. Okay, so that's how you use unit multipliers for squared measurements. All right, so let's take a look at this problem. It says use 4 unit multipliers to convert 125 square centimeters to square feet. Why don't you go ahead and pause the video and give it a try. I'm curious to see how you do it on your own. And then unpause the video and we'll go over it together. All right, so hopefully you gave this one a crack. We're going to do it together here, so don't feel bad if you got stuck. We're going to be going over it. So use 4 unit multipliers to convert 125 square centimeters to square feet. So it's kind of nice to first just kind of label what we're trying to do. We're starting with centimeters, right? And we're going to feet. And actually, we're going square centimeters to square feet. Okay? So, if you think about that, we need to think about our unit multipliers for centimeters. And centimeters, we're trying to get to feet, so we could try to think of, okay, if I have 1 centimeter, how many feet is that? Well, you probably don't know that. So we need to start with something a little simpler. And that's why they say use 4 unit multipliers. So what they're saying is, you don't know centimeters to feet right away. So let's start with something we do know. We do know how to go from centimeters to inches, And then we could go from inches to feet. Okay, kind of step our way up. So if we start centimeters to inches, we might think, okay, well, here we go. I do know that 2.54 centimeters are equal to 1 inch. So I can write this unit multiplier, 2.5 centimeters on top and 1 inch on the bottom. Now remember, this has to equal 1, so always double check yourself. Is this the same in the numerator as in the denominator? It sure is. It would be equal to 1, so that is a correct unit multiplier. Now we can always reverse these and write it the other way around. 1 inch over 2.54 centimeters. That would also be a unit multiplier. All right. So that would be getting us from the centimeters to the inches, because we have centimeters and inches over here. Now let's look at, maybe we'll just block that off here. So we've got this, that's the first piece of the puzzle, but then we need to go from inches to feet, right? So let's think about, our unit multipliers for inches to feet. And you might say, okay, well, let's see, I could say 1 foot over 12 inches, that would be equal to 1, right? They're the same lengths on the top and on the bottom. So that's a unit multiplier. And then, of course, I can always just flip it and have it go 12 inches over 1 foot. That's also a unit multiplier. So there we have some unit multipliers from inches to feet. All right, so now that we have kind of our list of unit multipliers that we're going to use as our tools here, now we can start working on the problem. So let's go back to black here, and we're starting with 125 square centimeters. So 125 centimeters squared, and we're going to write that over 1. All right, what are we going to multiply it by? What unit multiplier? Now remember, we're trying to go from centimeters to the inch to start with. We're not jumping all the way to the feet. So if we go centimeters to inch, which one should we use? Well, we want the one where the centimeters is in the denominator so that we can cross cancel these centimeters out. So that would be this one right here. So we're going to multiply that by 1 inch over 2.54 centimeters. Now remember, this centimeters squared, that's the equivalent of centimeters times centimeters. So this centimeter here would cross cancel one of those, but we need to cross cancel the other as well. So we're going to need to multiply this again by the 1 inch over 2.54 centimeters. Okay, now we can say, good, this centimeter is going to cross out this centimeter is going to cross out this centimeter, and we got rid of all of our centimeters, which is perfect. All right, now we just have inches left over. Now remember, we're still trying to get to the feet squared here. So from the inches, we're going to multiply this by our next unit multiplier down here, which deals with inches to feet. And we want the inches to cross out, so we want the unit multiplier with the inches in the denominator, which is going to be this one. So we multiply that by 1 foot over 12 inches, and this inch will cross out with this inch, because this is all multiplication. There's no addition in here. This is all multiplication. And remember, the order in which we multiply doesn't matter. So I can take this fraction and multiply it by this fraction first if I want to. And that's kind of what I did here. I just took this inch, crosses out this inch, but we still have another inch here. So we need to multiply it by another unit multiplier, 1 foot over 12 inches. Now this inch can cross out this inch. All right. So now looking back, we can see in our numerator, all of our units are crossed out except for feet. In the denominator, we don't have any units. It's all numbers. That's what we want. So what do we end up with? We have 125 times 1 times 1 times 1 times 1. So we have 125. And then we've got, what do we have for units? All the units are gone except for a foot times a foot, which is going to give us a square foot, or foot squared, or foot to the power of 2, however you want to say that, over, what's our denominator? We have a 1 times 2.54, 2.54, and 12 and 12. I'm not going to multiply these out. Actually, you know what? We're just going to write this down here so that we have a little bit more room. So it's 125 feet squared, and I'm just going to write this, and you can do this too, as 2.54 times 2.54 times 12 times 12. All right? And that is my answer. All right? Do you see how we did that? And again, you can multiply all this out. You can reduce all of this and make it look nice. But the goal here is really just to make sure that you're seeing how to use these unit multipliers so we won't get bogged down with all the multiplication. You can just leave it as this, 125 over 2.54 times 2.54 times 12 times 12 feet squared. Don't forget your units. Very important in your answer. All right? Great. So hopefully that makes sense to you, Luke. That's about where we're going to stop today. So look in the OneNote homework section for your assigned problems for this. And as always, be sure if you have any questions, if you get stuck on one and you're just lost, go to that page in OneNote, which I put in there for questions. And just put the number of the question down. And, you know, do the best you can. And we'll go over that together on our face-to-face class on Wednesday. All right? So I think that's about where we're going to stop, though. So let me know if you have any questions, and I will see you in Lesson 11.